The energy equivalent to 1 kg of matter is about. Again, we use the same relation. Binding energy or E energy is equal to mc square. Here the mass is 1 kg, where c is the speed of light, that is 3 into 10 raised to power 8 meter per second. So by putting these values, we can find out the energy of 1 kg matter, and that is about equal to 10 raised to power 17 joules. This is the correct answer, 10 raised to power 17 joules. Then next MCQ included in this reduced labels is 9 and 10. Ninth MCQ is which of the following are the basic forces is able to provide an attraction between the two neutrons. In case of neutrons, there will be two forces. One is the gravitational force because of their masses, and the strong nuclear force, that is they are residing inside the nucleus. Then last MCQ is the bottom quark carries the charge. As we know that the charge on the bottom quark is minus 1 by 3. Then conceptual questions of this chapter, which are included in reduced labels. First one is, why does the alpha particle not make physical contact with the nucleus when an alpha particle is headed directly towards the nucleus of an atom? First of all, nucleus or atom, they do not have a sharp boundary. Also, the nucleus is positively charged. So also, alpha particle is also double positively charged. So when alpha particle are positively charged, alpha particle are bombarded on the nucleus. Then due to the mutual repulsion between these two, and the alpha particle cannot directly head towards the nucleus. So because as the distance decreases, the force of repulsion increases. Second question is, why do heavier elements require more neutron in order to maintain the stability? As we know that if the number of, in case of heavier elements, the number of protons or Z number or proton number increases. So in the nucleus, the proton also increases. So and the force of repulsion there between the proton will also increase. So in order to stabilize the nucleus, the number of neutrons must be increased. So in order to increase the strong nuclear force, so it can maintain the stability and the energy states for which the distance between the proton is larger, that is being occupied by the neutrons. Because strong nuclear force is operated within a distance of 10 raised to minus 14 meters. So for heavier nucleus, so all such energy states are taken by the neutron, where the distance can be greater than 10 raised to minus 14 meters. So in order to increase the stability or increase the strong nuclear force, the number of neutrons in heavier nuclei are greater as compared to proton. As in case of uranium, there are 143 neutrons, whereas the number of proton equals to 92. And third question, that is an alpha particle has twice the charge of beta. Why the former does reflect less than the later when passing between electrically charged state? As we know that the charge alpha particle has twice charge, but its mass is 4 times, mass number is 4, so its mass is very large, or 7360 times. It is more massive as compared to that of electron. So they have high momentum, and when they are bombarded on an atom, so they do not get deflected. They move along a straight line unless they reaches very near to the nucleus, where they get some deflection. So that is why they do not get deflected unless they reaches very near to the nucleus. Then next question included in the reduced labels is, why are heavy nuclei unstable? The answer is again same. The heavy nuclei are unstable because their binding energy per nucleon is less as compared to the middle mass region. So the binding energy per nucleon of heavy nucleus is less than the binding energy per nucleon of the intermediate nuclei. This low binding energy of the heavy nuclei is due to the Coulomb repulsive force between the protons within the nucleus. So, due to greater number of protons, the Coulomb repulsive forces in heavy nuclei increases, which decreases the binding energy per nucleon. So, the binding energy, so this decrease in the binding energy makes the heavy nuclei unstable. And the last question is what is the color force? Color force and the force that is existing between the quarks is known as color force. This color doesn't mean the visual color as in our daily life. This only represents the parity or the property of that force. Since quarks make up of baryons, and a strong interaction take place between the baryons. So the color force is the source of strong interaction, or that strong interaction is like the residual color force, which extend beyond the proton or neutron to bind them together in the nucleus. So this is the basic force which is binding the quarks or the nuclei. And quarks are said to have three colors, that is red, green, and blue. And antiquarks have the color anti-red, anti-green, and anti-blue. The force that exists between them is called the color force. And the only numerical problem included in reduced labels is the first one, that is to find the mass effect and binding energy of the helium nucleus. In case of helium nucleus, the Z number or the proton number is 2, and the mass of proton in AMU is 1.00728, and neutron can be found by subtracting the mass number and the atomic number. 4 minus 2 equals to 2, so it also contains the 2 neutrons, and the mass of neutron is 1.0087 atomic mass unit, whereas the mass of the helium nucleus is 4.002602 unit. So we can find out the mass defect by using this relation. Delta M is equal to ZMP plus N into Mn minus mass of the nucleus, where Z is the atomic number, MP is the mass of one proton, and N is the number of neutron, Mn is the mass of one neutron, where MkZ is the mass of nucleus. So by putting the values, we get the mass defect equals 2.3038 unit. And in order to find out the binding energy, we have the relation delta mc square, or we have direct conversion factor, that is 931 MeV. So we just multiply the mass defect with 931 to get the binding energy, that is equal to 28.29 mega electron volt. Thank you very much.